Routing between VLANs with layer 3 switching. Okay, I'm going to assume, starting this nugget, that you have a knowledge of what a router on a stick is all about, right? Flyby review. Let's just say this is VLAN 20. On the left side, we have VLAN 10 hosts in there. We would configure this router with sub-interfaces, one for VLAN 10, one for VLAN 20. This guy as a trunk port, which passes all VLAN traffic down to this router. And so anytime this guy on the left wants to get to the right guy on the right, he goes to his default gateway, which is the IP address configured on that sub-interface. The router receives it, flips it, tags it with the other VLAN, comes into here on the trunk port tagged, sends it across to the other switch, and then is able to reach this device in VLAN 20. That's the whole idea of a router on a stick. Now, what's the problem with a router on a stick? Well, it's slow. When it comes down to it, we have to leave the switch in order to communicate with that router on a stick. So this link becomes the bottleneck, and the router themselves are slower than switches. Switches are all ASIC based, and this gets into kind of a bigger discussion. Can we replace routers completely with layer 3 switches? No, you cannot. The beauty of routers is their features. Why? Because they are software based, and you can actually load up a new version of software with new features without replacing any hardware whatsoever. Yes, the features will not be as fast as if you had a chip that actually did the functions of that feature, but they will give you the feature nonetheless. Whereas a switch has everything done, well, I'll say most things done in the hardware, the ASICs, application specific integrated circuitry, which are chips designed to do specific functions. That's how a switch can switch at wire speed as fast as the cable can transmit, and it can route actually at wire speed using the functions of these ASICs. So the switch, the layer 3 switch, will always be faster than a router until we can get the router totally ASIC based, which probably will not happen. So things like routing, things like access lists, a lot of pretty cool functions can be integrated into those ASICs. However, when you get to features like NAT, some of the advanced quality of service features, advanced forms of security, I mean, the switch just doesn't do them because they are software based features. So just think when you think of routers compared to switches, because some people are like, oh, well, routers have a limited lifespan and they'll all be gone and replaced by switches. Maybe someday, but I don't see that anytime soon, as long as we can't mass produce hardware that does all of these functions. So think of the routers as the features but slower, whereas the switches are like these are like the workhorse that do easy repetitive functions. I think of like, you ever seen like the cooking shows where the guy's got those Jinsu knives, and they go to a big old chunk of sausage and they're like, and they're like machines and they don't cut off their finger or anything. That's kind of like the switch, right? With the ASICs, is it does very basic repetitive functions. So features that are very basic and repetitive and can be put into the hardware are done by the switch, but when you get to some of the more advanced stuff, that's where we need a router. So routing itself nowadays is done by our layer 3 switches quite well in the hardware. So that's what we're here to discuss. So let me take my drawing pen up another notch and say, where did the router go? Well, with a layer 3 switch, what we do is we actually combine the functions of the router into the switch itself. We do that through switch virtual interfaces, SVIs. Might be a new term for you, but you've probably seen it before. If you ever go onto a switch, let's just grab switch 2 right here, and do a show IP interface brief, you see all your physical interfaces on there. VLAN 1 is sitting right there. That is a switch virtual interface, right? It is virtual, as in there's no actual port that represents VLAN 1, but all the ports, which actually right now are all of them, that are assigned to VLAN 1 can reach that interface, meaning when we give that interface an IP address, it's reachable. So switch virtual interface is just configuring more of them. Instead of having a router, out here that we say fast Ethernet 0/1.10 or something like that for VLAN 10 and configure that sub interface to respond for VLAN 10, we create a switch virtual interface for VLAN 10 and give it the same IP address. We assign an address to where this thing becomes a kind of a swouter, a router and a switch combined together, and this starts responding to the ARP messages. It does the functions of routing for that device. I mean, so all of those things can be handled by that switch virtual interface. So that's where we're going to go in this nugget. So let's recreate that scenario and then chalk through it. So what I've done here is gone Christmas colors on you and set this guy up in VLAN 10 over here, 10.1.10.50. You can see I drew up the subnets as well. This guy over here in VLAN 20, 10.1.20.50, right, is his IP address. Now what I haven't done is created the switch virtual interfaces. So we'll do SVI for VLAN 10 will be 10.1.10.1/24. SVI hang on. SVI for VLAN 20 will be 10.1.20.1. Now, notice what I'm doing here. Only one switch in this picture is configured as the layer 3 switch, meaning has the multiple SVI interfaces that can be used to route between them. Now, I just exploded with questions. Could we have this guy be the layer 3 switch as well? I would say not normally unless you had redundancy in mind. So this is where we get really trippy, really cool. We can actually go in here and say this guy will also has SVI 10 with 10.1.10. Let's just say 2, right? This guy has SVI 10, or wait a second, not 10, but 20 with 10.1.20.2, right, as its IP address. And I know you're like, where are you going here? Hang on. We bust out a protocol like VRRP, or Cisco's version, HSRP. I'm choosing VRRP because that has a unique feature that lets you use your virtual IP address as one of the assignees. So what we could do here, check it out, is I could go in and I could set up this virtual routing redundancy protocol, that's what VRRP stands for, to say, okay, this guy has .1 and I'm going to start a heartbeat between these two, to where if this guy ever goes down, heaven forbid, this guy takes over and actually takes the responsibility for those .1, that's a .1 addresses that used to be on that guy. And now, obviously in this small scenario, you're like, well, you lost half your network anyway, it doesn't matter. But usually in a bigger network scenario, there's bigger, better redundancy and more design. So anyway, that's so to answer the question, you would only do multiple switches with the SVIs in a scenario like that, usually, to where you're looking for that kind of redundancy. Otherwise, and keep in mind, hang on, let me get the X off my switch here. Keep in mind that layer 3 switches, and I'm even hesitant to say this, used to be far less common than layer 2 switches. Meaning, in the old days, let's say 5 or 6 years ago, layer 3 switches were very expensive and very restrictive on how many of them you could purchase because of their cost. And so you would just put 1 or 2 of them and they would do the routing for the whole network, and all the others would be layer 2. But nowadays, layer 3 switching has become like a commonplace, almost all switches have it kind of feature. Matter of fact, I'm telling you, if you're looking for watch Jeremy turn into marketing Jeremy. If you're looking for a sweet switch for a lab, small office, Cisco SG300. Okay, it's not a real Cisco switch. It's kind of their small business, previously known as Linksys series of switch. But I'm telling you, that thing rocks. For like $400, $500, you can get a power over Ethernet, gigabit Ethernet switch that has layer 3 functionality inside of it, command line interface that's so close to the iOS. I know it's not the iOS. It's like, I can't believe it's not butter. It's so close to the iOS that you'll be able to figure it out. Use the question mark just to kind of navigate your. It's awesome. But that's not what we're here to talk about. But that is a great switch if you're ever curious. They have many different versions, 48 port, 24 port. Anyway, the layer 3 switching is becoming commonplace. That switch has it. A lot of quote unquote lower end switches have it nowadays. So you can have all your switches potentially be layer 3 switches, but you'll only have one. To answer the question, yes. Thank you. Thank you, sir, for that question. Now let's talk about the configuration. Okay, I'm going to go to, let's go and just, we'll march right on through. So this is, again, from ground up, VLANs, switch virtual interfaces, and routing. So I'm going to go into switch 1. Let's do a config T, VLAN 10. We'll create that guy, exit back out, VLAN 20. Those are the 2 VLANs we're using in this case. Good. So those are created, and we've got a little... looks like GNS3 love telling me that we don't have enough space for the VLAN database. So now I'm going to verify that those VLANs are there. Oh man, seriously? No VLAN database? What's going on? VLAN 20. Well? I thought it was. Hang on. Wait, maybe I'll go old school on this. VLAN database? Does that work? VLAN 20. Huh? Oh! Why do you do this to me, GNS3? Please hold. Well, I have an idea. Let me try this. Exit. Abort! Stop! I'm just going to do this. By the way, this is not a good practice on a normal switch. But I'm just going to wipe out the flash memory because, you know what? This is a lab, and I can blow up things like that in the lab. So hang on, let me pause. I'll come back once my flash is erased. Well, I'm fidgety. While we're waiting, why don't we go configure switch 2? Let's see if this guy has any issues. So I'll do VLAN. Let's go on here and do VLAN 10. Yeah, that looks good. VLAN 20. Yay! All right, so we've got VLAN 10 and 20. Let's take a look at switch 2 and just see what we're doing here. Okay, so we've got the switches interconnected on Fast Ethernet 1/6 right here and right here. And then we've got the host in VLAN 20 on port 1/1. Okay, so let's go in there and let's do interface Fast Ethernet 1/6 switch port mode trunkage. Let's go into interface Fast Ethernet 1/1 and we'll do switch port mode access, switch port access VLAN 20, right? Because we're on switch 2 right now over there on the right hand side. So that guy's there. And meanwhile, I think we're probably still just blowing stuff up here. Okay, so I'm going to come over here to the host. This guy doesn't have an IP address, so let me just kind of get these guys out of the scene for now. So these are our PCs being simulated. So I'm going to do VPC1 show IP. It's got nothing. IP, and we'll do 10.1.10.50/24, 10.1.10.1. And that should give it its IP configuration with a default gateway of 10.1.10.1. And that's good. So let's hop over to VPC2. Hit the up arrow to 20.1. 20.50, checking for duplicate address. Okay, good. Okay, so let's just, while we're waiting for switch 1 to kind of make its way back, and we'll see if that flash erasal takes care of it, let's just do a ping. Ping 10.1.20.1. Oh, duh. Because we haven't configured it yet. We need to go in and configure. Those are going to be on switch 1. You know what? I think those are better placed on switch 2, actually, come to think of it. What if, I know, you're like, what's happening here? Switch 1 is temporarily under construction. Switch 2 actually just became the layer 3 switch for our session. So let's go in and configure it with the layer 3 interface. I mean, same concept, right? We're just flopping over to a different switch. So we'll come back here and do interface. So again, quick note. I type in VLAN 10. What do I create? A layer 2 VLAN, right? That I can assign ports to, but doesn't do any routing. Interface VLAN 10. What did I create? A layer 3 interface, more specifically a switch virtual interface that is able to handle routing for that. Now, I know some devices, by the way, we do need to type in IP routing. This one is kind of an ether switch router combo, probably not necessary here, but just a good practice to get into because some switches, layer 3 switches, have routing turned off by default. So we'll get back under, it's not where I wanted to go, under that interface VLAN 10, and we'll do IP address 10.1.10.1. 255.255.255.0, right? Let's do a no shutdown on that guy just to make sure. It's never a fun troubleshooting experience. So we'll do interface VLAN 20. And we'll get the no shutdown there as well. By the way, just a rule of thumb. Usually, if the VLAN is operational, the interface comes up by itself, like we can see there. And if it's not operational, meaning there's no VLAN that exists, or there's no ports in that VLAN, then the interface will come up administratively down. But that's just a rule of thumb, not a hard and fast rule. I've seen different things on different switches. Okay, so interface. Hang on, am I in which? How did I get here? Interface VLAN. Let me make sure I'm under the right interface. Somehow I went under the VLAN 10 again. Interface VLAN 20. Okay. And then I'm going to do the IP address 10.1.20.1. Good. So now I should be able to, I'm assuming that interface is working. Good. Ping that device, just verifying that it is truly getting to this device. I'll do a show ARP. This guy now knows about that virtual host sitting over here on 1. Now let's see if our switch 1 has recovered yet. All right, it has. Let's see if it works. This is just a theory. We'll see if it works. VLAN 10. That's good. VLAN 20. Hey, it worked. So if you ever have GNS3 and VLANs aren't working, then just erase the flash. I have no idea of the long-term ramifications of that, but it works for this demonstration. So now switch 1, we've got to do the same kind of configuration, right? Global config mode interface, fast Ethernet 1/6, switch port mode trunk, get that guy trunked over. Interface, fast Ethernet 1/1, switch port mode access, switch port access VLAN 10. Yeah? So if that's all right, I mean, we should now be trunking, so this guy can actually come in right here, cross the trunk, and ping the swouter, the router inside of this switch, on that SVI 10, right? So let's verify that that can happen. I'll do a, actually I'm on the wrong device. 1, flip over there, show IP, ping 10.1.10.1, and that's not working. Let's troubleshoot. I always tell people if something works right the first time, I forgot what I was gonna say. Okay, hang on. Fast Ethernet 1/1. We've got in VLAN 10, right? So this guy's here. Hang on. Why are we not reachable? All right. So Fast Ethernet 1/6. Let's do a show. Hang on. I just want to make sure that we're not just kind of. Hey, okay. It just took some time. You know, sometimes when you bring up the interface, let's just verify that. He's showing up in the RPA. Okay, sometimes when you bring up the interface and ping it too quick, yeah, you know what I'm trying to say, right? So we're good, right? So now the ultimate test: can I ping from PC1 to PC2, thus verifying layer 3 switching? And then don't worry, I'm going to trace this packet flow. So I'm going to do a ping 10.1.20.50, right, from VPC1. Golden. So we are now going across. So hang on, let's trace the packet flow, right? What are we doing when we do this ping? Okay, so I'm going to go green on you. So this guy comes out here saying I'm going to ping 10.1.20.50, which is this guy over here. He comes up here. First off, he ARPs for his default gateway, right? Who is that? 10.1.10.1. So let's just follow the ARP message. ARP message broadcast hits this guy. Maybe these guys are in VLAN 10, so it comes out there as well, but also goes across the trunk. When it does, the trunk is going to put that little tag on there saying you belong to VLAN number 10. So that ARP message comes across, the broadcast hits here. Let's say this guy's in VLAN 10, he gets a broadcast too, out that fast Ethernet 1/4. But also this guy, SVI 10, responds to all packets in VLAN 10. He goes, oh, that's an ARP message for me, 10.1.10.1. So the swouter, router inside of the switch, responds and says, here is my MAC address, PCA, over on the left-hand side. So PCA then goes, great, now I'm going to send my ping, which is actually an echo message, to, and we would see the IP address of 10.1.20.50. That's where he's trying to ping. But the destination MAC address, remember, this is why we always have 2 addresses, will be whatever he received from the ARP message to that SVI, right? So that then comes in here, out this trunk, hits the SVI. The SVI is like, great, you're doing routing, and I'm seeing that you're trying to reach 10.1.20. That's a connected interface. Exactly the same thing that router on the stick would do that we had at the very beginning of this nugget. So it's, this guy gets it. He's like, oh, great, I just received a packet. I'm now going to route it down to this guy in VLAN 20, and then this guy comes back up. You get the flow, right? So instead of leaving the device, going to that external router on a switch, this all happens internally inside of that switch. Matter of fact, let me just go in there. This switch really is a router. I can do a show IP route, verify that it has a routing table. Notice it's got connected interfaces, one in each VLAN. I mean, as you get bigger with this thing can run routing protocols. It really is a nice full-featured router. So layer 3 switching in all its glory. I hope this has been informative for you, and I'd like to thank you for viewing.